Now the second thing we want to talk about in this section is free fall acceleration. Free fall acceleration is any time an object's accelerating due to gravity, just the force of gravity. And the force of gravity always pulls objects towards the center of the Earth. So this acceleration will always be pointed towards the center of the Earth, which in our case is usually thought of as down. We always think of what we feel as down as towards the center of the Earth. The acceleration of any falling object, when we do not include air resistance will not be included in most of the problems that we cover in this course. You can assume that air resistance is not included unless it is otherwise stated. So the acceleration will always be 9.81 meters per second squared towards the center of the Earth any time that an object is falling, when that is the only force. This is the same for every object regardless of mass, and this was first discovered by Galileo. Now, a couple of key things to think about when an object is thrown upward into the air if it's just not falling. If it's thrown upward into the air, it's going to have two parts to the trip. It's going to be traveling up and then back down. These would be straight on top of each other if there's no horizontal velocity. So it's going to have an initial velocity. The key point is it's decreasing in speed as it rises. It will decrease in speed until it reaches the highest point. At that highest point, the velocity is always 0. Then it will gain speed coming back down, still accelerating at 9.81. It accelerates at 9.81 down the entire time. So when it's traveling up and accelerating down, it's going to be slowing down. So slowing down as it goes up. And then speeding up as it goes down. It will reach a final velocity that is the opposite of the initial velocity when it gets back to its original starting height. So whenever you throw something up into the air, if it starts at say 10 meters per second, it will decrease that velocity until it gets to 0. 0 will be the highest point, and then it will pick back up that velocity, increasing in velocity, now going down, so being negative if we make up positive. And it will reach the original starting point at the opposite of the initial velocity, so negative instead of positive. The acceleration the entire time is 9.81. Even at the highest point when it is not moving, it is still accelerating at 9.81 down. So let's look at some example problems with this concept.